Ashley Williams, thank you so much for joining us today. I know we just had emerging technologies for the enterprise. We had you speak about Rust, and thank you for doing that. I wanted to kind of talk around kind of the edges of Rust itself, since people can watch your talk when it goes live. I don't want to completely duplicate the talk itself. Um,
Totally fair. Though I'll
but
admit there's so much in Rust that, and I think I
yeah,
even say this in the talk, but like each topic itself could probably be multiple talks.
right. And I have a few things I want to dig into. So some of it might feel like it's a little bit of replacement of it, but I guess the first thing is, when did you discover Rust itself? Like, how did you kind of go into that community, and what got you hooked?
Yeah. So it's probably worth mentioning that I have been in the open source world for a reasonably long time at this point.
Hmm.
Um, like when I started teaching myself to program, and I'm self-taught, my degree is in philosophy and neuroscience, not computer science. I was convinced that I wouldn't be sitting at a computer for my job for my life, but here we are.
I
Um,
think therefore I compute. Yeah.
um, but yeah, anyways, so I'd started out in my very first programming job was actually teaching programming. I taught Ruby. Then I was like, oh my gosh, this JavaScript thing is happening. And in the moment when all the Rubyists were like, JavaScript's not cool, I was like, I don't care if it's cool. It's going to be really important. So we should teach the
Yeah.
students it. And so I started getting into JavaScript, and that was right around when Node started happening. So I was like, I've got server side skills from Ruby. This JavaScript thing is happening. I dove just like head first into Node. And I love the technology. I was primarily teaching. And one of the things I started noticing was just like this whole idea of like, what is an open source community? And what should
Hmm.
community dynamics be like? And at the time, there was some frustration, I guess I'll leave it at, with the Node community. And so I did a lot of work there. And that was very difficult. But as I was doing that work, there started being rumblings of, hey, there's a new kid on the block. It's Rust. And they really care about community. And I was like, huh, I wouldn't know how to start writing an operating system if I tried. I have no idea what systems programming is, but I love teaching and I love technology that helps people do stuff they thought they couldn't do before. I was like, all right, let me check out this Rust thing. And I loved it. It was really exciting. I'd always loved exploring like what I would call weird languages. Like I had taught myself Erlang a couple of years before that, not to be
Weird
an
language.
Erlang developer, but because like that translation exercise
Hmm.
reveals so much about what programming can and cannot be. I feel like it expands your imagination of things. So I started learning Rust, and I was like, this is really cool. And I started working with my partner on this toy operating systems project called Intermezos, because I was like, all right, systems programming, operating system, like let's just try. We did like
Hmm.
a test driven VGA driver for an operating system, and
Oh,
that
that's a
was
good
super
challenge
cool.
too. Yeah, that's a
It
really good
was super
challenge.
difficult, and I had to write some assembly, which I had never done before. And people talk about bad error messages, bad
Huh.
error messages. But I actually, so what I ended up doing was giving a talk at the very first Rust Fest. And Rust Fest is the kind of traveling non-US like Rust conference. They kind of do events in Asia, Europe. I don't know if they've done one in Africa yet, but maybe. Anyways, they've done a ton of conferences, and I spoke at the first one, which was in Berlin, and I gave a talk on this operating system project. Really, mostly like a, if you thought you couldn't write operating systems, like you can, because I did, and look at me. And I actually made a mistake and didn't expand the length of a buffer when I was like changing it from Hello World to Hello Rustfest. And I
Mhm.
had been talking about how error messages are fantastic developer experience, and it gave me this horrible error message, and people thought I had staged it, but it was actually just a mistake I had made. But anyways, yeah. So, and then at that Rust Fest, they had the very first Rust bridge. And if you're familiar with Rails Bridge, it's kind of this workshop that's designed to go alongside an event. And it's for anybody who hasn't done that before, to kind of get them going in it. So then they can go to the event and like feel like they really know what's going on. And I had started an initiative like that for Node called Node Together. So I went and I was like, okay, these folks really like Rust, but a lot of them hadn't taught before. And so I was like, oh my gosh, I want to work together. Like, let's work on this. And so I started getting involved in Rust Bridge, and there's much more that comes after that, but that's kind of the start.
Okay, cool. And so boy, talk about no time like the present. I opened up a Rust tutorial today. What time is the interview? Noon. So, but I wanted to, I've seen a little bit of it before, but I want to just, kick the tires on Rust in an IDE. So there's a nice little tutorial on the Rust website. And by the time I was like, finished with the simple random number generator guesser game and started playing around with packages, I installed like the Rust Analyzer and stuff on the tooling on IntelliJ. First I was in Visual Studio Code, then I switched over to my favorite, which is IntelliJ. And man, so I think you had mentioned in the talk something about like some people will say Rust is hard to learn, but I have not seen a more helpful compiler. It basically tells you in almost polite terms, like, this is not supposed to be reassigned because you did this wrong. And it has nice, really good descriptions about things, and like you were saying. So
yeah, I was gonna say I gave a shot to Esteban Cooper, and I have to continue to. Sufficiently empathetic compiler is kind of the rallying cry of Rust developers, and we feel really strongly about it. And so, yeah, I mean, like, as far as batteries being included, like, you get like 800 little helpers along the way with Rust. But I think one of the reasons, and I didn't get into this too much in the talk, so it's great to talk about this now, is I think one of the reasons people really struggle with Rust is that Rust has its own way of doing things. And so if you come from a language where you have built kind of like a view of the world and like how the world should be, and like, this is how you write things that are fast, this is how you write blah, blah, blah. And you come to Rust and you hold that original view you had very rigidly, you can have a really rough time in Rust. So one of the questions I get like all the time is like, how do you know if you're writing idiomatic Rust? How do you know if you're writing fast Rust? And one of the things that I know I at least felt when I was learning, and I've just seen play out again and again, is like, how much are you fighting the borrow checker, right? How much is the compiler going like, this is just not, like, when you start getting into a piece of code where how you're writing the program is just like a constant battle with the compiler, what I like to tell people is like, instead of just continuing to fight, like, a lot of people will start, the error messages are great, but you can dig yourself into a hole where things start getting really weird, right? Much like any, I think, programming language, edge cases are complicated. But you can dig yourself into a hole, and people will find these things and be like, all right, well, I really, really, really want to do it this way. How do I get Rust to do it this way? And what I tell people is you're going to have a much better time with Rust if you go, this is the problem I need to solve. What are the different ways I can approach it? And like, okay, maybe my original approach was not the right one, because Rust isn't closing doors on you. Like, there's a way to get it done. But especially if you're coming from garbage collected languages, very heavy OO languages, and you try and use those patterns that you're used to, it's going to be brutal. One of my favorite keynotes from RustConf is by a games developer. Her first name is Catherine. I forget what her last name is. But she talks about developing games in Rust. And she talks about how a lot of those original, very OO patterns can cause like a lot of struggle in writing in Rust. And she talks about kind of shifting your mindset to writing games using an entity component system. And there's other paradigms, but the idea is that you might have to kind of change how you think the universe works in order to have a great time with Rust, depending on what you're writing. And I think the more flexible you are in that viewpoint, like, the better time you're going to have. And so people used to think it was ridiculous that I was teaching people who had never programmed before Rust. But it was not nearly as difficult as I think people believed it to be, because they didn't have these underlying assumptions that can often steer you in the wrong direction.
And it's not as cryptic as like Kernighan and Ritchie's C for a beginner. You know, when I started programming, I think, well, I should say when I started programming something that resembled business programming anyway, in the early 90s, and I hit C and I looked at it and went, this is going to take me way too long to get anything done because I'm not that smart. I mean, everyone has some level of smart, but I
don't know.
I
wouldn't say it's
and
about
I didn't get
being
along.
smart. I think it's more about, like, to a certain extent, how much time you have and like what layer of abstraction is interesting to you or you are incentivized to be interested in.
Right.
I don't know. I definitely don't believe anybody has a certain level of smart, I guess.
I'm obviously being silly here. I'm being silly. But at the same time, you're absolutely right. There's a business problem in front of me. I want to solve it. Does the language or the tool meet me at that level where I can get stuff done without like saying, I need another 6 weeks. I need another 6 weeks, another 5 weeks, another 8 weeks. Because
you have to reinvent the universe before you can solve the problem.
Boil the earth. Yeah. Boil the oceans. Yeah. Boiling the earth is much worse than boiling the oceans, I find. Got to be a lot hotter.
I feel like there's a climate change comment in here somewhere.
There must be. Yeah, I think it's coming out. So, all right. So kind of veering into this territory of like, why Rust kind of is ultimately more user partnering, so to speak, than like some other languages. It seems like a lot of the ideas that Rust has, and this is with every language, there's a lot of things that kind of grow up around each other in different languages, right? I look at Scala and then I look at I look at Rust and Neil Peart, and I see like, okay, I see some innovation that kind of started with Scala-like languages and then kind of wended its way, like the pattern matching, for example, beautiful, but also comes from a lot of other languages. How does the Rust core team get their inspiration for what to put in the language? And also counter to that, how do they keep things out that make it a horror show if you're not careful?
So I think the first thing I'll say is that is not exactly the role of the Rust core team. So Rust has really kind of, I think, very unique governance. And I think it's one of the origins of Rust's strength. Yeah. So Rust has very distributed and delegated governance. And so the core team sits kind of on top, but the goal of the core team is basically to kind of coordinate otherwise fully autonomous teams across the project. So for language features, for example, we have a language team, and they work very closely with what is another autonomous team, which is the compiler team. And so they are like fully delegated to be in control of those things. And so how they work, I mean, the thing that you're describing, I think, is the capital H hard problem of like building any product, like at all. And I think Rust's hypothesis, and I say it's a hypothesis because it's a living project and we'll like see how it does. It is still young in many ways. The hypothesis is that if you get a diverse enough set of people in the room, you can kind of have that wisdom of crowds and be able to, learn from other communities, learn from previous experience, and be able to like use many different perspectives to like come to a great decision. And so like the way language features happen is the same way all major decisions happen in the Rust programming language, which is through the RFC, or request for comments process, which now that we are no longer a very small project can be very intense and involve conversations with a lot of folks. And so I also mentioned that I think how the language team has worked and how just major decisions in the project in general have worked has worked great for a while. But as we we've hit an inflection point a while ago, I think.
Mhm.
But that's something that I know a lot of the teams are paying attention to. And the language team in particular is really leading the way in innovation there. I know they've gone from just RFCs to major change proposals, and kind of reviewing things there. So, and trying to be, more public and transparent about how they work to solicit more opinions. Um, but yeah, I mean, it's tough. This is a hard thing to do well.
Yeah, it's fun to watch all these languages kind of grow up around each other. Because I mean, I even go back, when I was working with Java years ago, I found this silly dynamic Java tool called Bean Shell. Right, this is many years ago, and Bean Shell was one you could like invoke, and you'd have a shell into like expressions in the running VM. And then they had Groovy and the Groovy shell, and Ruby came along as a dynamically typed language. All these things grew up around each other. So there was like the closures and lambdas and stuff like that, the passing functions into things world. So that's why I see all these things grow up, and it's kind of fascinating.
Yeah, and I mean, I would be remiss to not say, like, a lot of people are like, "Oh, Rust is so great," and I'm like, we had the benefit of coming much later.
Yeah,
And
prime
we,
movers have a hard
instead
time.
of inventing things from first principles, there was an immense amount of like learning from others, I think, both from academia and from industry, which I think also really helped. Um, but like, for example, Yehuda Katz did a ton of work on the tooling, and he was prolific in the Ruby and JavaScript communities.
Yes, he
So
was.
there's
Mhm.
a lot of borrowing for sure.
Not only in the code, but also in the code.
Yes, no, the
Yeah.
puns will continue.
Yeah, I can't stop myself. I apologize. It's part of the title
No,
of
it's
the
okay.
show.
It's very rusty of you. The pun game in the community is truly next
It's
level. I
strong.
mean,
Yeah.
you know about the mascot?
No. See,
So
this is
people who write Rust are called
mhm.
Rustaceans,
I've heard of
and our
that. Yeah.
mascot is a crab, and the crab's name is Ferris, as in like of or pertaining to iron. Anyway, yeah. So
Oh,
it starts there and just keeps going.
it just keeps on going. It's like the Python team with all the Monty Python references. Yeah. Um. So okay. So another thing. Um. One of the things I thought was interesting about Rust when I was looking through some of the documentation is that when you do things where you're running in debug mode, it's really kind of helping you. Like I looked at, for example, the with numbers and underflow overflow, that it's going to let you know during debug mode that something's happening there. But in runtime, when you go into production, it's a little different. Can you talk a little
When you
bit about
say debug mode, what do you mean? You mean when you compile
not
it?
building for production? Yeah. So like when you're
Ah,
like you built with debugging into it, I guess is that's the best I can explain with my extremely limited understanding right now. But I mean, are there other things that happen kind of when you're not built for release that Rust helps you out? Or is that
um,
just a tangential thing that happens to happen for like numbers and stuff like that?
well, I guess I'm trying to think of if there would be any specifics I would call out. I mean, I don't know. Yeah. I mean, it's the kind of just classic trade-off, I think, between, compiling for debug and production where, optimizations, when you're optimizing for both size and speed, you're going to eliminate a lot of information.
Hmm.
And in debug, you're able to keep some of that information around so that you can end up having much better error messages.
Yeah, if I remember correctly, it was something about you if you underflow. I forget if it throws an error or not during debug, but I know in when you're in release mode or whatever you're saying when you're building for release,
Release,
it
yeah.
does a two's complement math. So it's like it's not going to blow up your code. It's just going to give you some odd results you weren't expecting, for example. So I thought that was kind of an interesting choice. Um, what is Rust's story about variables and mutability? I like how by default everything is immutable. So, but there's certain rules that they add in addition to that, right? Just to keep you from making really big mistakes.
Yeah, so I mean, this really jumps into the type system and a lot with how, lifetime and borrowing works. I gave the example in the talk of if I lend my book to you, right, and I want to read it later, I shouldn't let you burn it. And so part of the reason that mutability matters is like whether or not something has a mutable or immutable reference is going to be important for those guarantees that we make. So, if I recognize that something has a mutable reference, we need to guarantee that it only has one. And if it has any immutable references, making sure that it doesn't have any mutable ones.
Mm-hmm. So let's talk a bit about cargo and crates, specifically around crates. And as you mentioned, you've been in the NPM community. I'm doing a lot of stuff on the JavaScript side, so I'm dealing with NPM all the time. And before that, I did a lot.
And I mean, I was going to say, I don't know if you remember package management in Ruby, but I actually ended up on the core team of Sinatra strictly because I was just managing the gem file for different Ruby versions. So
yeah. So my question is around governance around that. So for example, in the Java world with Maven, everything goes to the central repository. You have to go through all sorts of checks and balances and make sure everything's up and running. And then in the NPM world, someone can like check in a version of Faker that has a silly message in it and blows up everyone's code that ever used Faker. What is the governance around crates IO?
So governance is a very interesting word here because it can speak both to like automated policies and then kind of what you could call social policies. Mm-hmm. So technically speaking, you need to have a cargo toml. The cargo toml needs to have the appropriate fields. And cargo will check to compile that code before it publishes them. Beyond that, there are no automated tests. Okay. I'm actually not familiar with what Maven may or may not do. That's very interesting.
It's more of a governance by the repo owners, so they give people the ability to publish based on agreements, essentially open source contributor agreements and things like that, if I remember correctly. And then it depends on who's running the repository. So I guess it's similar, like a honesty policy, so to speak, with the library maintainer. Have there been any issues with cargo and things being like unpublished, or has that kind of stuff happened more?
You can say left pad. It's okay.
Left pad. Yeah, the one I was using was another
funny
one like that
story.
Too.
I worked at NPM during left pad and was really central to the unpublished policy getting written.
Oh.
That was something that was very important to me. So cargo, I would say the immutability guarantees of the crates.io registry are significantly higher than NPM's, though not 100%. I think it's important to just kind of recognize that like any registry, like that is any community registry that is on the internet today is going to necessarily have some mutability. People change their names. That's a big one. DMC takedowns are a thing. Trademark is a thing. And I'll put a little warning in here that trademark does not work the way most people think it does in these types of situations. Oh my gosh, I could give a whole talk on trademark. I'm not a lawyer though. But what you can do is you can do your best to make it as immutable as possible. So originally in NPM you could publish a package. It could be up for like 3 years, have 5 million dependent packages. You could just take it down. So that is not the case in Rust. We have something called yanking, which, if I recall correctly, comes from the Ruby world, but there's other places that have that. And so, I mean, this is probably potentially getting into too much detail, but cargo has a cargo lock file similar to the package lock file. And what yanking does is it's going to remove that version from like public search results. It's not going to let somebody put that version in a new cargo toml and have it downloaded. But if that version is in your package lock file, like that file is still going to exist up in the registry and it's not going to break your code, but it will print a warning and encourage you to update.
It seems like a reasonable middle road between both, where it's too
Yeah.
restrictive, but then you can't do a takedown, for example, and you legally have to. So,
Yeah, I will say,
that kind of
well,
thing.
depending on the DMC takedown, whether or not it's a gank or if it's a full pull, like
Mhm.
it's very
Things get
interesting.
messy.
I
Yeah.
suspect that would not be a yank. Yank is like a tool that we give in place of an unpublish to end users. Now, I've described yank in probably the most like naive possible usage. There are, like all package management stuff, ways that it gets complicated. So
Yeah.
not necessarily a perfect solution, but I do think a better one. I will offhandedly say that I think when I was doing the unpublished policy for NPM, one of the most important, I did a survey of like, why do people want to unpublish? Like what is the point? Why do you want to unpublish this so badly? And in general, it really had to do with people wanting to remove their name from like abandoned or like otherwise like not used projects or.
That's interesting. Yeah.
So, I mean, one of the original solutions, at least when I was at NPM, was like, okay, what if we came up with a way that you like donate the package to like put an NPM user there, or move it somehow. Like people don't want to delete the code; they just don't want it showing up on their profile anymore. But I mean, that is also a very complicated thing. And I mean, we see this exact same thing in the Rust ecosystem. There's a lot of like really promising projects that folks are using, and then that original author needs to step away. There's no one to step in to take it.
Yeah.
What do you do? And how do you transfer it to a trusted entity and not like a not trusted one? I mean, at the end of the day, a lot of this boils down to the fact that like we haven't figured out how to sustain open source commons yet in a way that's reasonable. That's a super big problem. But yeah, it is very interesting. But at least I'd say with Crates.io, again, learning from the past, I would be less worried using Crates.io than other community package ecosystems.
So you're working. Oh, I want to ask this first. So WebAssembly. I know you had looked at WebAssembly and did some. Am I correct saying you did some work on WebAssembly?
I was very involved in WebAssembly for a while.
So all right. So let me throw this at you. So where is WebAssembly today? I know that you can take code, for example, you could take C code and stuff like that and transpile Doom onto the browser, for example. Crazy stuff like that.
Doom, AutoCAD,
Yeah,
those
right.
big demos. Yep.
But like take up the memory in your browser and crash your computer, all that fun stuff, or whatever, or maybe not. Where is Rust in the WebAssembly game? And have you seen some good and novel or interesting uses of WebAssembly through Rust yet? Or is it still, we're all still trying to figure it out?
Oh my gosh. So yeah, and I would say in around the like 2018 to like 2020, honestly, still to today, like I think Rust has one of, if not the best WebAssembly story compared to a lot of the other competing languages. So one of the things that I think is very interesting about WebAssembly, and you'll note that a new second version of the WebAssembly spec, WebAssembly 2.0, landed about a week ago, I think.
Timing, what do you know?
WebAssembly was this technology that I feel like kind of always had this identity crisis. Like even in the early days, it was like WebAssembly, neither web nor assembly. And it was like, and everyone was like, of course, like that's cool. Like naming, it's hard. Who knows? But like the original vision, I think, of WebAssembly was really like, there had been this attempt, like, how can we get something more with a systems performance kind of characteristic in the browser, right? And so it was like, in a way, it was like, how can we have a standards-based like Flash? Like, how can we have something like this? And people had been attempting to do these things for years. Their large companies all had different attempts at this. And so when Rust was originally kind of talking about its WebAssembly story, and this is when I was participating in that, It was about, okay, how can we build a tool chain so that people can supercharge their JavaScript? So a lot of the tooling here was, how can we make the experience of writing Rust fit into the software development lifecycle that JavaScript developers are the most familiar with? And
I'm going to take
how
a
can we
moment here.
make WebAssembly interop with
Right.
JavaScript in a seamless way? And there's so many technical considerations for that. And I could go deep into it. And I think there's still a future for that. But what I'll say is, I think the timing, and so I worked on the WebAssembly toolchain for Rust for a while. And then I moved over to, I went to work at Cloudflare on their serverless edge product, Workers. And I think the rise of cloud computing, cloud native, or whatever you might say, and kind of serverless and the edge, I think alongside some kind of fatigue with client-side JavaScript and spas, like the idea was like, do we really want like a fat client that's just faster? Or do we want cloud computing where the network lag is less, like where we can have easier ops? And so I actually talked about this with great sadness, but I think I've come to make peace with it in my life. Is I think WebAssembly is a cloud compute technology. It's where the money for WebAssembly is right now. The money for supercharging your JavaScript and browser, not so much. I mean, browser funding is a whole complicated other topic. But I think with WASI, which is the WebAssembly system interface, and there's some just really fantastic things. Fastly's got a really cool kind of runtime thing going on. You're seeing a lot of different companies kind of coming out with, what if we use WebAssembly as a Docker replacement? And so that's what I think you're really seeing today. And I think that is where WebAssembly is probably going to be, at least for the next couple of years.
I was going to interrupt you because, and that's rude of me to do, so I apologize.
You're fine. I just went. I'm sorry. I could
I'm like, get out of the way of the train.
I have so many feelings about it, but yeah.
Well, I just laughed because when I first got involved in Java, Java was the big, hey, browser, you're going to get so cool because you got this little gray window that shows up and does nothing for 45 seconds. And then throws an exception in your console and maybe shows a button, and its goal originally was to be JavaScript's best buddy, or JavaScript was to be Java's best buddy. And there's a symbiosis, and Java kind of grew out and immediately away from that into server-side programming, and we never looked back. Well, some people look back and try to create Java FX, and I'm not so sure about that, but and Swing and all that stuff before it. So it's interesting to see like another technology grow out of the browser and the web, only to find a much bigger home, because the ultimate goals of Or to write efficient, fast, safe software, which is kind of interesting. With Java, it was the garbage collection piece, which was the safe software, and running on many platforms was its goal there.
Yeah, I mean, WebAssembly and garbage collection is a very spicy space right now.
I'll bet, yeah.
For a long time, like I used to say, like WebAssembly, like the reason I was really excited about WebAssembly in the browser was its performance characteristics were just significantly more predictable, largely due to its lack of garbage collection. Now, its lack of garbage collection caused the idea of WebAssembly being like a compilation target for like any language in the universe, while still remaining small and fast, like was kind of impossible, because it's like, oh, okay, now you have to like bring your own garbage collector. And that really, really stymied, I think, WebAssembly adoption, because it kind of was like, okay, you can use Rust, you can use C, C++. There was assembly script, which was kind of like a complete rewrite of a language to kind of like look like a subset of TypeScript. And those were your choices, or you had to bring your own garbage collector. And that as somebody who was trying to like pitch WebAssembly at the time, that really slowed people down.
It seems like there's a lot of dragons in that, lots of really weird, strange edge conditions that would be thorny and hard to deal with, I would think.
Yeah, I mean, that isn't really the worst part of it. I mean, I know at least with Cloudflare Workers, like I was hired, they were like, make WebAssembly work on Workers, and it's a V8 isolate. So like WebAssembly already worked. But the idea was like, okay, if I want to compile Go and put it in a worker, I got to bring a whole bunch of Go with me. I don't fit anymore. And the whole point of using WebAssembly was that it was small. So that's, and like, having to bring that along with you, it's a ton of bloat. So trying to figure out how to manage that was very complicated. And then that's not even to dig into like the performance characteristics going across the boundary of like when you're dealing with, strings or something, like how memory gets handled there, passing that from say JavaScript to WebAssembly without having garbage collection. That gets complicated and can end up with performance characteristics that you don't want.
You were, and I've looked at some of your references in your bio, that you're the author or lead maintainer of a number of different tools. So one of them was Cloud for Wrangler. It sounds like that was one of the things you were working with there. How did you get involved in doing some of these other tools like WasmPack and Cargo Generate and stuff like that? Was that kind of like one of the ways you got started working with Rust, was writing utilities, or these were as you started working with it, you saw we really need a tool for this and let me jump in and build something?
Yeah, so I would say, the way I really got involved in Rust was teaching Rust. And then I think inevitably when you teach a lot of people, you kind of understand like what are the spots that trip people up? What are the repetitive spots? Yeah. How can you glue stuff together? So Cargo Generate, for example, and I still to this day hope that we figure out a way to like kind of build something like this into Cargo, is the idea that a lot of people love starting with kind of a demo or a scaffold. And we actually built this, and by we, I really mean Kat Marchand was the primary author of this, but this idea in NPM where like create React app, I think kind of started it, but it was like, there's like a template, I want to use the template. And instead of just using Git to like clone it down and then like change it all, like what if just my tooling, like let me specify that, and it just kind of scaffolded it out for me. And so that's what Cargo Generate does. And it really came out of building a bunch of things and like having like template galleries and things. Like, how can we connect these two? And like WasmPack, for example, like uses Cargo Generate under the hood to like initiate like a hello world project for you if you were to run like WasmPack init or WasmPack new. I forget which one it is. So yeah, it really came out of teaching and having an empathy for that beginner experience and trying to think of like, how can we get people out of their own way? Let them focus on the stuff that they care about.
Right. If someone's starting out, it seems like there's a decent amount of getting started stuff on the Rust language site, but what are some good resources for people learning Rust? Is it on the Discord community? Is that a good place to hang out? I saw there was a beginners forum there that looked pretty lively.
Yeah, so I think it depends on how you like to learn and also where you're coming from. So one of the things that I love about Rust, and I made this slide for like a RustConf 2018 keynote, I think, that was like the Captain Planet, where you have all the different kind of things coming together. Rust can have brand new beginners, college professors, like people coming from C, people coming from Python. And a lot of teaching is that, to go back to what I said at the beginning, this idea of translations, like find out where you are and then how to connect it to where you need to go. And so depending on, I think the first thing to know is like figure out, kind of like reflect on like where you're coming from as a developer. There's a fair number of really cool, like I know there was like a Rust for Rubyists project for a while, Rust for JavaScript folks. Like look for some of those bridge technologies. I think a lot of communities now kind of have the like, those are the JavaScript people who are like interested in Rust now. And they tend to have really Josh Whites, for example, has a really great introduction to Rust for JavaScript developers that I think is great. But then I know at least, like, I think the book does a really good job of introducing, and by the book, I guess I mean book.rustlang.org. It's like the official book. It's free. You can buy a paper copy. Proceeds go to charity. But I think it does a really good job of introducing the like primary concepts. But I think nothing really beats like having a toy project that you just kind of build in all the languages you learn and like trying it out. And this used to be, I think, like a really tough thing, particularly for web developers, of which there's many, because like I want to build a website in Rust was, just a couple of years ago, kind of painful. I mean, there were some great early actors, like the Rocket project, I thought was really, continues to be really cool. But that story has just gotten so fantastic today, with especially improvements in async, that, whatever the thing is that you like to build, like try and build it in Rust. And that's usually the fastest track to like figuring it out.
Is there a Rails for Rust concept? Is there a good simple, or I should say Sinatra for Rust is probably better, because is there a short, simple stack for network access and sending things back and forth on the pipe that's really easy comparatively to use? Or is it just Rust is really friendly to hook into for network access and such?
Yeah, so this is a very complicated question to answer, kind of hilariously. Like my brain is like going through this whole like decision tree. So I really did like I think the Rocket project, and I think they've improved this. Rocket, I think, was probably the closest to kind of like looking like a Sinatra, and was the earliest, but it relied on nightly features. Rust has 3 release channels. And so figuring out, again, Rust comes with a version manager. Switching channels is like easiest in Rust than I've seen it in many other languages, but that can still be a stumbling block. And also nightly is every night. So like, who knows, you wake up and now your stuff's broken. But I think they fixed that. The reason they depended on nightly features is, so Rust has macros, and Rocket uses macros to really like eliminate boilerplate and kind of generate everything for you. There are lots of other ones though, and so you could really pick any. One that I kind of have my eye on is Axum, AXUM. That's coming out of the Tokyo ecosystem. So Tokyo was one of the earliest ecosystem movers in async. So they've been doing that for a while. They have a request library, QWEST. Those folks, and there's many people working on it today, but Carl and Sean were some of the first people who started it, and they were just really fantastic folks. And I also know I forget, I don't know if Tide is still, but there's truly a lot. I think I would say find the tutorial that you are most motivated by and use what that tutorial suggests you use. This is a really fast moving spot in Rust, and like this is immediate technical debt for like if someone watching this in like 6 months, probably they'll be like, why did she say that?
Right, now I gotta change to something else. Yeah, exactly.
No, yeah, exactly. So
the reason I ask is because, like, you look at like Ruby wouldn't have gotten where it was, I think, without Rails catapulting it along for everyone to have a really useful server. And then you've got on the Python side, you've got its ones which are now escaping me at the moment. And then we got Spring for the Java world. But so it sounds like there's a lot of innovation going on right now. Not any one of them is one, so to speak, in terms of having a large bevy of users that everyone's switching over to yet, but there's a lot of choice.
Well, I think there's a few that people are really switching over to, but it's controversial. So another one that I think is really fantastic was a project called Actix, and it had Actix Web. I say was just because there was some controversy, and this would be a whole nother live stream, but like, what does unsafe in Rust mean? And why do people get spicy about it? So, and I don't think that the way that played out in the community was particularly great, but it was a really great project and tons of people use it. So I think what we're seeing, in the like network library ecosystem in Rust is kind of like a clash of tastes and trade-offs. Rust has in general been really good at centralizing on things like even with error handling, usually like there's been tons of experimentation in the ecosystem, but usually kind of there's not like two fighting each other. Usually like one will happen, everyone's like, this is great, but it could be improved. And then another one will come out and we're like, great, that's the improvement. You'll see a lot of just transition to that one. Whereas I think in the web ecosystem, and it's not surprising to me because the web has always been kind of a spicy place, right? People make different trade-offs about what matters to them. And like web, as far as web developers, is a really diverse space. So I think that there was always like this desire to potentially even promote, one of these things to the Rust standard library, because we'd love to centralize things if it makes discovery of stuff so much easier. But there's some really distinct tastes out there. And I think just picking one, like, I don't think there's ever going to be one right answer. So I think much like people talk about, JavaScript and framework fatigue and things all change there. And they often attribute that to JavaScript developers being hype machines and just loving the new next thing. But I think I have a different perspective, which is just how the web gets used, where you draw trade-offs and why. I think there are several good right answers, and everyone's just kind of circling around those, going back and forth between them, trying to figure that out. So I think we'll see a lot of experimentation in Rust there for a super long time. But I think it's generally really positive.
It's funny. It's same with this. You said SPA fatigue, but a lot of people have started off in tools like, they had like jQuery and then a lot of hand-built frameworks, and then Angular came along, and a lot of people said, it's a framework. It gets a lot of stuff done for me. But then other people were like, you know what? We really just want a component library. So React came about. And then Vue came along and said, why don't you do both? And your head explodes. You're like, why so many of these things? So it's fun to watch how these things evolve for sure. Well, Ashley, thank you so much. I think this has been a really useful talk, at least for me anyway, and hopefully for our viewers, as a good adjunct for your talk. If you attended ETE, you'll see her talk within the next week or so online, and everyone else will get it in about a month or so. And then this is a good kind of thing to hitch along with it and take a look at some other things we didn't have time for in the actual ETE presentation. But Ashley, thanks so much for spending time with me today. I really appreciate it.
Yeah, thanks so much for having me. And I'm just really excited to see more people get excited about Rust. I think it's a really fun project. And I hope people not only use it, but also consider kind of getting involved in the process of building it.
Thanks so much.
All right, bye.